Imagine this. Your banking app suddenly gets 5 million users trying to log in at the exact same moment. Would your application survive? Probably not, unless there's an invisible army working behind the scenes. That army is called Kubernetes. And in the next 8 minutes, I'll show you exactly how Kubernetes works, from the moment a user sends a request until your application responds. By the end of this video, diagrams like this will actually make sense. Let's start with one simple question. Why was Kubernetes even created? Imagine running a restaurant. Customers keep coming in. Some days, 10 customers. Other days, 10,000. Now imagine hiring waiters manually every time more customers arrive. Impossible. Applications had the same problem. Containers made deployment easier, but managing thousands of containers became a nightmare. Google solved this internally, then open sourced the idea. That became Kubernetes. Think of Kubernetes as an operating system for your data center. Not for one computer, for hundreds. Let's zoom out. Everything inside Kubernetes is divided into two parts: the brain and the workers. The brain decides. The workers execute. Simple. Imagine Amazon. The headquarters decides where a package should go. Delivery agents actually deliver it. Exactly the same idea. Let's meet the brain. There are 4 important components: API server, etcd, scheduler, and controller manager. Let's understand API server first. Every request enters here. Think of it as the reception desk. Nobody walks directly into the CEO's office. Every visitor checks in at reception. Similarly, kubectl, CI/CD pipelines, developers, everything talks to the API server. It validates requests, authenticates users, stores changes. etcd. This is Kubernetes memory. Every object, every deployment, every node, every secret lives inside etcd. It's a distributed key value database. Lose etcd, and Kubernetes forgets almost everything. That's why production clusters always back it up. Now imagine someone creates a pod. Which machine should run it? The scheduler decides. It checks CPU, RAM, affinity, taints, node health, then chooses the best worker node. Think of an airline assigning passengers to seats. The passenger doesn't choose. The airline optimizes everything. Controllers constantly compare desired state versus actual state. If you ask Kubernetes to keep 3 pods alive and one crashes, Controller Manager immediately creates another. Nobody has to log in, nobody presses restart. Kubernetes heals itself. Welcome to the workers. Every worker has 3 major components: kubelet, container runtime, and kubectl. The kubelet. The supervisor. It receives instructions, starts pods, checks health, reports status. Think of it as a site manager at a construction project. Container runtime. This is the actual engine, usually containerd. It pulls Docker images, creates containers, runs them. Remember earlier? Kubernetes itself never runs containers. Container runtime does. kubectl. Now imagine hundreds of pods. How does traffic reach the correct one? kubectl maintains networking rules, load balances requests, keeps services working. Think of a traffic police officer directing cars. Let's follow one request. Step 1. A user clicks login. The request reaches the load balancer. If HTTPS is enabled, SSL terminates here. Next, ingress controller. It checks host, path, rules, forwards the request. Now the service takes over. A service has a stable IP. It chooses one healthy pod. Finally, the pod processes your request. Response returns through exactly the same path. Congratulations! You just understood the entire Kubernetes request flow.